Alright, 8.7, number 45. So use a graph utility graph the path of projectile is launched at an angle of theta, so an angle of 55 degrees, with initial velocity of 210 degrees or 210 feet per second. In each x, use the graph to determine the maximum height and the range of the projectile. Also state the time in which the projectile reaches its maximum height, time hits the ground. Okay, and the ground is flat, and just gravity. Okay, so these are given to us in calculus. We will derive them. I guess it'd be Calc 2 or Calc BC is where we'd be dealing with polar calculus. But the x is always going to be this, the y is going to be this if we have just gravity working on it. Okay, so our x equation is our initial velocity, which is 210, cosine of 55, and all of that is just a number, and then times t. And our y is negative 16 t squared plus our initial velocity 210, sine of 55, and all of that times t. So we can enter those. Let's see, x is 210 cosine 55 t. I recognize that we're in degrees now, so before I forget, I'm going to go mode degrees. And my y is negative 16 t squared plus 210 sine of 55 t. Alright, so we have our equations. I know our window is not going to be even close, but I'm going to graph it, and there goes the projectile. Alright, so it's going pretty fast off the screen, so I need to go to the window, and I'm going to, so my maximum time is going to is 18 seconds. That's plenty of time for it to hit the ground. My t-step, I'll leave it at that. I might want to decrease it a little bit, maybe 0.05. X min, well, we don't need it to be very far to the left, but the negative 10 is fine. But the X max, how far does it go? I don't know. I'm just gonna guess 1,000 maybe. And our Y max, I'll say 1,000 also. Those will have to be adjusted a little bit. And I'm gonna graph it. Alright, so I need, the Y max is fine. My X max, I'm going to have to go a little bit further to the right. It's still working because we asked it to go to 18 seconds, so I'm going to hit on, and that always stops the calculator from graphing something. Window X max, I'll try 2,000. Okay, so there is the projectile launched at angle of 55 degrees at 210 feet per second. So all of the questions can be found analytically, especially using calculus, but for right now we're just going to let our calculator do the work. So I'm going to hit trace, and we're going to find the maximum height. You can see this is 2 seconds, 3 seconds, 4 seconds. Maximum height looks like it might be right around, I don't know, right there. So it looks like it takes about 5 seconds to reach. I said 5.25. I mean, it could be somewhere around 5. I'd say 5.3, whatever. Okay, so it's traveled 638 feet horizontally, and it's 462 feet above the ground when it's at the maximum height. Or that is the maximum height, and that happens at 5.3 seconds. They also want to know when it hits the ground and how far it travels, so I'm still tracing it here. So once my Y is 0, that's pretty close. So it takes about 11 seconds to land, and it travels 1,294, so maybe 1,300 feet it travels in the air.